This is the third and last part of my excursion to the Black Forest. You saw this guy briefly in the last video? He gave us an absolutely amazing tip. Fluoride. And now we have to take some with us. Marvin was even more excited than I was about the uranium finding. But what is fluoride? Fluoride is another name for fluorspar, or chemically speaking, calcium fluoride. It's a relatively simple mineral from a chemical perspective. Calcium fluoride is one of the go-to examples when it comes to the AB2 structure type, often introduced early in inorganic chemistry. In this structure, calcium ions are cubically surrounded by 8 fluoride ions, while fluoride ions are tetrahedrally surrounded by 4 calcium ions. Such a textbook perfect structure is rarely found in nature, and where structural defects occur, you can find some truly fascinating specimens, like in this video. So, calcium and fluoride ions, but I will come back to that later, but for now, let's go and collect some. A bit of off-trail hiking and climbing uphill led us to this piece of disturbed earth. Prime territory for finding beautiful specimens like these. But of course we weren't the first ones to be there. Fluoride is a highly sought after mineral, so some folks really had gotten into this hill. This isn't something you do with a simple shovel. Cutting such a trench requires heavy equipment. I get it to some extent. Humans have been digging up colorful stones for thousands of years. But I don't get not cleaning up after yourself. The vein goes straight up and is of excellent quality. I mean, check out this gorgeous blue color. I must admit, I was so fascinated by it that I barely filmed anything.
Das ist eine Fluoridader, die hier hochgeht.
With a hammer and a splitting wedge, I chipped off a bit myself, but there the rock was already so solid and hard that I didn't get much out of it. However, even the loose pieces lying around were incredible.
Oh, das sieht auch richtig gut aus. Das ist doch irre, ne? Wie viel die da abgetragen haben, ne? Einen halben Berg, ja? Ja.
With full pockets, we climbed back and happily headed into the car to take our loot home. Here's what I've found. We found blue fluoride. Pure calcium fluoride is colorless, but the mineral also occurs in purple, gold, yellow, green, pink, brown, and a few other colors. Fluoride is relatively soft and breaks easily, making it unsuitable for jewelry. It forms when ions dissolved in water crystallize out, often containing impurities. Not all of these are present in our specimen, but they are among the factors contributing to coloration. As with many well-known minerals, pure compounds like aluminium oxide or silicon dioxide are colorless, and trace elements add color to it. But that's not the whole story. Other effects can also contribute to coloration, such as F-centers. F stands for Farb in German, meaning color. For this example, an electron might be missing. But why? The reason is ionizing radiation. I mean, this is a channel focused about radioactivity. What else do you expect? Yes, uranium and thorium can also cause coloration through radiation. Think of smoky quartz as a well-known example. I really like this piece because I chipped it off myself, and you can clearly see how the vein is placed inside the rock. The exact reason for blue coloration of this particular fluoride might be too complex to determine, but under black light there is a faint blue fluorescence. And I've read that some yttrium contamination is responsible for the blue. By the way, it's no coincidence that fluoride and fluorescence are linguistically related. Many fluoride fluoresce in various colors. The blue fluorescence, for instance, comes from divalent europium ions trapped inside the structure. I already had some fluoride in my collections, like this banded Chinese fluoride, and it's representative as my sample of fluorine, because our favorite fluorine chemist, Professor Florian Krauss, and 2 other scientists proved that elemental fluorine F2 exists in a variety of fluoride called anthozoite or stingspat. Due to the presence of radioactive elements, fluoride ions in fluoride can be oxidized to fluorine. Using solid-state F19 NMR spectroscopy, They were the first to demonstrate that this highly reactive element not only exists as fluoride ions, but also as elemental fluorine in nature. I love this story so much that I tell it pretty much everyone who claims that my fluorine sample isn't really fluorine. And with that, our excursion to the Black Forest is over. Many thanks goes out to Marvin because I've learned so much from him, and I would highly recommend you watch other videos with him on other channels, which I've linked down in the video description. Also, a huge thank you goes out to my patrons, and with that being said, thank you for your attention and goodbye.